And therefore, as a free man, I take pride in the words, Ich bin ein
Science! Science!
I know the human being and
Science!
can coexist peacefully.
This was thou findest.
Hey guys, this is Nathan Allen,
This is Sean Allen.
and you're joining us for episode 2 of Petri Dish. So guys, maybe you're like me, you're walking down the grocery store looking for the bottom pack of all the other carne asada flapjacks that's written off 90% because they know where it's been and you don't know where it's been, but that's your life. And maybe you've seen a couple things, Impossible Meat, Beyond Meat. Wait, what is it again?
Impossible Foods.
And what's the other one?
Beyond Meat.
Okay, so Beyond Meat, Impossible Foods. And to me, it's kind of like, it's amazing blasphemy. Like, what is it? We've been watching the Jetsons our whole lives. Maybe it's just me. But I've been watching the Jetsons all night, every day for years. And finally, we have food like them. Food that's made in a lab. Food that's invented by a scientist somewhere to be extra delicious, to be perfect. It's Beyond Meat. And I want to know, what is it exactly? What makes it Beyond Meat, Sean?
Yeah, so the ones you were bringing up, Impossible Foods and Beyond Meat, they're like veggie burgers.
Wait, when you say veggie burgers, you mean like they're, but they're Beyond Meat, right? Like they're the future.
Yeah, as in like when you get Beyond Meat, then we're just talking about like plant proteins.
Aren't they really just not meat then? I don't feel like they're beyond anything at that point.
Well, I mean, just the main point.
It's not impossible meat, it's just possible vegetables.
So, you know.
So sad.
Impossible Foods, most of the protein is from soy. And then aside from the soy protein, kind of their big interesting thing is that they use heme. And heme has iron in it, and that's what makes it red and kind of bleed. And they actually do that in a pretty cool way. They use GMO yeast that they like transfer the gene for. You got a face on your face.
I'm just so sad.
Yeah, I'm sorry, dude.
Well, I want the lab meat, man. I want the science meat. I want meat of the future.
Sure.
I feel like all the magic's gone. Like I opened the wardrobe and it's not Narnia, it's just James McAvoy naked.
Well, look, baby, don't worry. I got lab meat for you.
What do you mean?
There's lab meat out there, and if you just shut your sweet mouth for a minute, I'm going to tell you all about it. So the other day, I was spending some of my free time, as I generally do, looking at these videos and GIFs of Korean cheer squads.
Sure.
And there was this one GIF that I saw where there was this entire kind of stadium side filled with these Korean dudes, and they were all moving in unison, and it almost made them look like an LCD screen. What kind of blew me away about that, and what made me think about biology, because I'm a nerd, was that there's this really extreme and intense coordination that needs to happen. But the way that I'm sure that this cheer squad did it was they coordinated their motions to a beat. So each individual person had to memorize a bunch of movements, and then there was some kind of beat that they would all do the movements to. And that's like definitely way more impressive than what I can pull off. But compared to what your body pulls off, there's almost no comparison, because your cells in an organ like your liver or in your muscles are not only doing their own intricate kind of dance to a beat, they are also paying attention to each other and communicating to each other. And
Is it to a heartbeat? Sounds like a Phil Collins song.
yeah, sure. So they're doing this really kind of intense signaling amongst each other, talking to one another. And the reason why I bring it up is because understanding where this complexity comes from and how complicated it is really going to help us understand the challenges for lab-grown meat. Because meat is a product of animal bodies, and that means that it's a product of a lot of cells communicating with one another.
So in terms of social acumen and general complexity of organization, you're like an archaeobacteria. A Korean cheer squad is like a eukaryotic cell in all its organelles. And then there's really nothing that humans do that's even comparable to the complexity of the human body.
So this organization that happens in your body with all these cells talking to one another, there's some terms that get tossed around that I'm going to be using, and so I want people to know ahead of time what I'm talking about, okay? So there's organs, all right? And I think people got a pretty good idea,
Like spleens.
Spleens, yep. We got liver, heart, kidneys, all that shit, right?
Testicles.
Yeah.
Are they an organ?
Yeah.
That's what I was saying that.
Testes are an organ? Yeah, good job, buddy.
That's cool.
Look at you.
But anyway, so you got organs.
And then you also have tissues. So the general idea is that a tissue is a collection of cells, usually of a similar type and for a particular kind of function. Whereas an organ is a bunch of different tissues coming together. Usually, again, for kind of this like larger scale function that requires the coordination of different kinds of stuff. And so the reason why I'm bringing all this up, because we're talking about lab-grown meat, is that lab-grown meat needs to have muscle, the muscle organ involved. And the muscle organ is made up of a lot of tissues. There's skeletal muscle tissue. There's vascular tissue like blood vessels. There's adipose tissue, that's fat. Connective tissue, that's like cartilage and stuff like that, and tendons, So when you're biting into a nice juicy steak, all of that is there. You know what I mean? You got some marbled fat in there. It's delicious, right?
That's a lot of words, but I remember The Matrix. And in The Matrix, I think they needed fecal transplants from humans. I can't remember what it was, but they needed some stuff from humans, and they had them hooked up, and it didn't seem that hard. All they had to do was make an entire fake reality for humans to live in, all humans all across the world, so there's no rebellions, which didn't actually work. It seemed pretty easy, though, anyway, in the first movie. So why is it hard to grow muscle tissue? All you have to do is make an entire fake reality for the muscles to live in a Petri dish, and they'll grow, right?
Aside from the words you using being weird about saying that that's easy, I kind of agree with you in the sense that like that is more or less the challenges involved here. Because these environments inside of our bodies are so complex, and it means, you start as a single cell and then develop through time into all of these tissues, all of these organs.
A single cell with a soul, though, from conception, right?
I can't believe it. How are you doing this every fucking episode? It's insane. How is this possible? I don't understand. It's like I can't talk about anything biological without you bringing souls and shit into this.
From conception.
Oh my god. Oh, it's rough. Oh shit.
But you were saying.
Oh, fuck me. Okay. Yeah. The point being that the organization that goes into making tissues and organs is really intense. And there's a lot of communication between cells. And at the end of the day, a lot of scientific work that we've done on eukaryotic cells, mammalian cells, human cells, has usually involved a much simpler situation. One kind of cell, grown in kind of a single sheet. And usually there's something like stem cells or cancer cells. So they're not really, they don't really care about being a super specific kind of cell like a muscle.
Sure.
So this is really kind of a much more complicated issue. But interestingly, the way that they do it starts out kind of the same that a lot of cell biologists who are probably not listening would actually recognize really easily. To start out with, you need cells from something.
Yeah, so this is step one of growing meat.
You got to find a cow somewhere. It still starts with the cow because you want to make that primo beef. So you need to take a biopsy punch or something of a cow. You need to get some muscle out of that cow.
Hey, what does that mean, by the way, a biopsy punch?
Yeah.
You mean like in House when they put the needle in something and they pull it out?
Kind of, yeah.
Okay, cool.
Yeah,
So we put a
it's
needle
like
in a
House.
cow and we pull some stuff out.
Yes.
Does that kill the cow?
No.
Oh, okay.
One of the good things about lab-grown meat is that you can get these cells out of a cow without killing it, and then the cows can go on to be the happy cows that you see in the old California dairy commercials.
Somehow that feels like a negative to me, but that's a moral thing, whatever. So if you get stuff from the cow, don't kill it, take it back, this biopsy. What do we do then?
So then you basically take the muscle that you got from that cow and you fuck it up.
Okay.
You fuck it up kind of like you would by lifting at the gym or something like that. And what that does is it disrupts the muscle and it activates these cells called myosatellite cells.
This is a really wonky question, but what do you mean by disrupting cells? Like, what is it that you're disrupting?
Yeah, so both mechanically, as in you take it and you like chop it up
Oh.
and you tear it, which actually is also what happens at the gym.
So when you work out at a gym, you're like committing genocide against like a bunch of cells in your muscles.
Yeah, but they're all you, so it's okay, right? You can self-genocide. That's a thing.
I don't know, man.
High
High on science, okay? I don't know if I support this. This is why I don't work out, okay?
I'm just...
Self-love.
So, you need to disrupt these muscles.
Yeah.
And doing that activates these myosatellite cells, which are sort of like the stem cells that reside in all of our muscles, and they're what help you recover from a workout. They're what builds the new muscle fibers.
Okay.
So then, you have these myosatellite cells, you put them in something like a Petri dish.
Help me visualize this real quick. Like,
Yeah.
you have your muscle cells, and they're all, like, connected through their membrane somehow. They're all holding hands. Mm-hmm. And then you work out and you commit genocide against your own body.
Yeah.
Working out's bad. But then these other cells, these myosatellites, so they come in and they, like, bring everyone back together. Or, like, they build a new bridge. Like, what's the metaphor of what they're doing?
Those torn muscle fibers are torn. Those myosatellite cells are actually already there. They're sensing that there's this damage around because
Okay.
signals get sent out.
Yeah.
And so they start dividing and then merging together into new muscle fibers.
Oh, that's cool. Oh, okay, I see. So they're the new muscle.
Right.
Right. So it's not that they're repairing muscle, it's that the muscle's dead. They
Right.
become the new muscle.
You are building new muscle, that's right.
Jesus.
Which is basically what happens in
To
this
nations as
Petri
they
dish.
grow stronger through war.
God damn it!
Okay, so the
do you
Petri
do
dish,
this to me?
It happens also in the Petri
Why
dish.
do I keep coming back?
You love me.
Brotherly abuse. So, in the Petri dish, you have these shocked myosatellite cells, and that shock makes it so that they start producing a bunch of cells. They start dividing,
Yeah.
and these new cells are called myoblasts.
Okay.
They're the early myoblasts.
That sounds like an awful DJ. Michael Blast.
Yeah, sure. And these myoblast cells, they're the ones that you get a bunch of in a Petri dish, and then you take those and you split them into a bunch more Petri dishes, and you have them sitting in this liquid that's supposed to be their food. It's called medium.
Yeah, I had questions about that, but let's keep going first.
Okay, so basically you need to give these cells food to grow,
Right.
and
That's what the medium is the food and
Right.
whatever the environment, like the
Right.
liquidiness.
right.
Yeah.
And the medium is really important, so I'm bringing it up now because it's going to come up later when we're talking about cost.
Right.
But suffice to say, at this point, medium is expensive and you need a lot of it for these myoblast cells to be happy. And then at a certain point, once you have enough myoblast cells, millions and millions, I mean, up to trillions of myoblast cells from one biopsy punch from grabbing some muscle out of this cow,
Yeah.
you take these myoblasts and you put them into a gel.
Okay.
This gel made out of something like cellulose or something
Sure.
like that. Usually cellulose and something called matrigel, which
Right.
I'll also get into later.
Like Jerry curl.
Yeah, guy.
Yeah,
Wait,
yeah.
what?
Keep going.
You say Jerry curl?
Don't let me sidetrack you.
Isn't that a hairstyle?
Don't let me sidetrack you.
Damn it. It's just so hard. You say so many words. All right, so now you got these myoblasts. They're sitting in this gel of collagen.
Okay, yeah.
And being in a gel and hopefully being seated in something that looks kind of like a ring makes it so that they'll form a ring of muscle fiber. Or really early muscle fiber.
Which goes straight onto your grill.
Not soon.
Okay, maybe not.
You need to give it a while, actually. Though the weird thing is once they start forming these muscle fibers, they'll start contracting on their own automatically. So you'll see
cool.
dishes where they're just going around contracting. And the interesting thing is contracting is weirdly like flexing or working out in that the muscle fibers will grow bigger by going through this flexing motion.
So they're like
They're
like getting
bro.
swole in front of you.
That is not fucking bullshit.
So they do have souls.
God damn. No, because cows don't have souls, do they?
I think they do.
Are you Hindu now?
I'm Asian. So what I'm hearing, right, is we have step 1 is get the biopsy of the cow. Step 2 is put these crazy protein shits, these cells, including what will become myoblastas, into a medium. Step 3, I guess, is them just growing, and you're the scientist. You're sitting back, you're drinking a pina colada.
Yeah, so they're kind of like stem cells, so they could divide a bunch of times. So you just keep them in the medium, and every few days you just check in on them, maybe give them some fresh medium.
Well, this sounds easy as shit.
Right, so this part ain't that hard,
Okay.
but we're not done yet. Once you have these guys and they're in the ring, they've been flexing for a little bit, right? They start to get built up. They're getting stronger, and at a certain point, you can see them. They're basically a couple of centimeters long and about a millimeter thick. And that's all growth from their flexing motion.
Would it look like meat at this point? Or is it like, looks like pulled pork?
It would look a little bit like thread that's kind of a yellowy color.
Okay.
Yeah, like a thick yarn of yellow.
Oh, man. Okay, keep going. I like this. Thick yarn.
Yeah, so once you have these yarns, you need about 10,000 of them to make a burger.
Wow, okay.
What this ultimately means is that from one cow sample, you end up getting about 800 million muscle fibers, but that translates to about 80,000 quarter pounders.
So you get the threads.
Yeah.
And then to make that quarter pounder, what do you got to do to make that quarter
Yeah,
pounder?
smush them together, and then from there,
Sure,
you
it's
just,
like ground beef, basically, so whatever.
well, smush them together and then put them into a meat grinder.
Okay, cool.
Yeah.
Wow, and that's 80,000 quarter pounders from that.
From one cow sample.
Okay. Well, how long does that take?
About a month.
Okay, well, that's a lot shorter than raising a bunch of cows, right? I mean, I don't know the life cycle of a cow. I haven't lived on a farm recently.
Yeah, me neither,
But
but
overall.
I think from birth to eating, it's probably longer than a month.
Okay,
Right?
well, you're probably. It's funny because we're probably right, but if we're wrong, we'd be so wrong,
Yeah,
right? Like
yeah.
there'd be some guy in Iowa who's like, "Oh man, I raised all my cows in 3 weeks."
Not a Heffenweiser heifer.
Yeah.
Those ones are just...
Okay, wow, a month, and then you have a bunch of burgers. This all sounds pretty easy. Why aren't we doing it now?
Basically, a few really, really big issues with this. Okay. And I'm going to go with what I consider to be the more solved issue first, and then the big kind of looming one in the background second.
The government, the fossil fuels industry has been buying it up, trying to stop the research.
Epstein. He did it.
They try to frame him.
No, fucking, we can't do this. Okay. One of the big things is that if you just make a burger patty out of these little meat dudes, these little muscle strands,
Yeah.
it doesn't taste very good.
Oh.
Yeah.
Well, I feel like you've been fucking me then, because you've been talking to me 10 minutes about awesome lab meat, and it turns out it's all dog shit anyway.
Well, here's the thing: is one of the major elements that's missing out of this is fat.
I thought you were gonna say umami.
No, they got plenty of umami.
They
That's
got
from the
umami.
protein. They got that umami. They don't got the fat.
Okay, no fat.
Okay, and you want that juicy, fatty burger. You want some of that fat in there.
I feel like you looked at my fat briefly when you said that. Okay, so
So fat.
yeah, fat.
Okay? You want that in there for the flavor, but in case you didn't notice, this entire time we were talking about how to make muscle fibers, myoblasts, and all this stuff. At no point did we mention cells that would actually be fat cells, adipose tissue, white fat. And because they're a whole different kind of cell, it turns out you need a whole different procedure to make white fat. You need to extract it at some point. A lot of times it's out of bone marrow. To get what are called mesenchymal cells.
Say that one more time.
Mesenchymal?
That sounds like a Yiddish insult, right? All
think-
these are zinkable.
I think it's an interesting thing that happens when you shove a bunch of biology prefixes together, because it's like
It just sounds like Yiddish.
it's like mesin and chyme all cells. So you can take some bone marrow, you can just grab some fat out of a cow. There's a few adipose stem cells in there.
Okay.
So there's different ways to be able to start the process.
Okay.
But ultimately, the main takeaway is that, yeah, it still has media. Yes, it still involves a bunch of plates of cells sitting somewhere. But first of all, it takes like 2 to 3 months.
Wow, okay.
Okay, so it's
So
longer.
it's double or triple the time to make fat than protein, because that's not how my body feels.
Right, exactly. Right? Why is it the opposite for us? I don't get it. Science needs to figure that shit out.
I almost feel like we should just take fat from people.
Right, rich people get liposuction. I feel like that was a major aspect of the plot of Fight Club.
Right.
Was making soap out of people.
Although that's probably also the roadblock, right? If we had a system of getting fat from like prisoners, we would already be eating prisoner fat. Wow. Right?
You're fucked up in the head.
I'm fucked up, dude. The system is fucked up. That's why I'm writing in these nuts, okay, for the 2020 election.
Oh my God.
Okay, change the system.
You're sick.
Okay,
All right.
man. So it takes a long time to make the fat.
So fat takes a while to make.
How similar is the process? Like, is it the same kind of medium, or is it like we got to invent a whole different medium?
Yeah. This actually segues a little bit into part 2 of why this is so fucking hard. So I'm just going to finish up the fat part by saying it takes a lot longer, right? That's the main issue. Because once you have the fat, once you have the meat, you can just mix them together in the grinder and boom, you got a patty. It's pretty juicy, okay? So, part 2. Why is this hard? Cost, okay?
Okay.
And so one of the things that it boils down to is you can have the same media for fat cells and for muscle cells.
Okay, that's cool.
But only if you use something called fetal bovine serum.
Okay.
Okay? And fetal bovine serum
It sounds controversial.
is serum
Okay.
from cow fetuses
Huh.
from pregnant cows that we're killing to get their meat.
Wow.
So,
Wow.
we take the blood out of the fetus.
I like that a lot.
And then we centrifuge it so there's no cells anymore, and it's just
Wow.
like the blood juice.
Oh my god.
And that's fetal bovine serum.
Wow. Okay. So maybe I was gonna say that maybe if we just change the word serum to juice, maybe that would help. But now that you've described it, I don't think it does because it's intrinsically horrifying sounding.
The issue here is that you and I both have the same sickness because juice was my proposal. Was freedom juice. Yeah, that's a bummer, dude. We got the same problem.
Fetal bovine juice.
So in any case, in lab we call it FBS, so that we don't think about any of those other words.
Right. Sure.
And FBS gets used in most media because a lot of cells use it just fine to grow. And if you leave FBS out, a lot of cells don't grow anymore.
Why is it better than fetal pig like serum?
Yeah, I think you get more juice out of the cow.
Okay. It being fetal bovine is incidental.
Yes.
Happens to be that we have a lot of cow fetuses.
Yes.
But the fact that it's fetuses, why does it matter that it's fetuses?
It might not matter that much in that you can use, for example, some cells grow a little bit better in goat serum or horse serum, and that's from adult horses and adult goats.
Yeah.
So some cells can grow a little bit better in different kinds of serums, but broadly speaking, fetal bovine is the most common one. Although, even for being the most common, it is extremely expensive. It's probably the top cost associated with growing cells in labs. And therefore is an extraordinarily high cost for making lab-grown meat if it's going to be part of the formula.
Yeah.
Right? On one hand, it's like, all right, well, if it's such a big moral and cost issue, like, this is one case where morals and economics might actually align a little bit.
Cool.
Like, cut it out then, right?
Right.
But we're not totally sure what's in fetal bovine serum.
Okay.
And we don't totally know why it's so good at getting cells to grow. So,
this gets to kind of a fundamental rehash I wanted to do, which is that, so we need the medium for the cells, and the medium is supposed to closely enough replicate whatever is in our body when cells, reconstruct, or tissue reconstructs from cells, that the muscle is basically the same, right?
yeah.
And so whatever that medium is then has to be like the human body. And what you're telling me then is that we don't actually entirely know what's in there.
Yeah, the serum has a lot of stuff.
Okay.
It's got a lot of stuff. It has a lot of, kind of more normal things like maybe sugars and these small molecules that are running around. But it also has a lot of different kinds of proteins.
Interesting.
In lots of different percentages and carbohydrates and fats. And, it just has so many components to it.
Like you said, the human body is really complicated and really complex, and it's hard in a lab to perfectly replicate that complexity.
Right. The people have tried.
Yeah.
People have tried to make what's called serum-free media. And what they have found, generally speaking, is that you can make serum-free media, but the cocktail of stuff you need to mix together is very specific to the cell you're trying to grow.
Interesting.
So when you take out the FBS, you kind of take out the universality of your media now. Now you got to make one really specific, otherwise the cells just won't give a shit.
So FBS just has like a bunch of stuff in it. We haven't figured out exactly what that stuff is. And so any attempt to approximate it really just ends up catering to whatever we're making in that moment. We can't capture the full complexity of FBS.
Right. And to this point, no one has made a as good as FBS media that's serum free.
Although
for muscle cells.
Okay, I see, yeah.
Yeah. On top of that, for fat cells, for adipose cells. So what that means is right now, the cost is kind of high because you have to use FBS. And on top of that, there's these kind of ethical issues. And if at some point lab meat is supposed to replace cows, like if we're like, okay, now all cows can be happy. You know what I mean? We don't got to kill them anymore because we've got lab-grown meat. If part of lab-grown meat is cow fetuses, that doesn't really match up, right? With like the whole idea of what we wanted this lab meat for.
Sure.
So we need to replace FBS. That's like one of the main hurdles here, is we need to be able to get rid of yes.
And that's maybe not an impossible hurdle, but a very time-exhaustive hurdle, while there are other things that you could be eating.
Actually, there is one more issue with
Jesus.
lab-grown meat. Yeah.
Just crushed my dreams.
So after you get over the media hurdle, get rid of FBS.
Yeah, the fetuses is what you're saying.
Right.
After we get over the fetuses.
Well, yeah, the little fetus ghosts. Yeah. Once you're past them,
Ghosts?
you have to deal.
There are ghosts, Sean?
They have souls. You said it already.
You scientists have been lying to me. Okay.
You get to the gels.
The Jerry curl.
Yeah, the Jerry curl gels.
Yeah.
And they're made out of a mixture of bovine collagen, which you'll probably need to replace.
Wow, I'm never going to use Jerry curl again.
And something called matrigel.
That's cool sounding.
And matrigel is stuff that gets secreted out of cancer cells grown in a dish somewhere.
Oh.
So while matrigel is very cool, and I use it in my own research, there's a lot of people who have concerns about that, and it's extremely expensive.
Is the concern that what's the concern?
That you're introducing different proteins and potentially cancerous cells in the matrigel that you're not totally sure that you got rid of everything from.
Oh.
And it's from mice. It's mouse cancer cells.
Okay.
So now you're adding a separate species in
Mouse ghosts.
to your meat. Yeah.
Now
you got. Well, I mean, it's cancer though, so I don't know if cancer gets a soul too. Let's calm down on the souls.
Well, all cells of conception have a soul.
Do it. All right. So matrigel is really expensive, and it's a cancer product. The collagen in the gel is from cows.
Yeah.
And we're trying to cut cows out of the equation here.
But we have failed so far.
Yeah, but we've already failed with FBS.
Wow.
But on the gel side, they're trying out some other stuff. They're trying some gels made out of kelp.
Okay.
Alginate, which is from brown algae or kelp. And so far, there's been some success with that. And so if they can use alginate, then they can cut out the matrigel and collagen.
But kelp forests create a neural network. And thus have our one living organism with full sentience. So I don't know if that's appropriate.
Yeah, I miss Alpha Centauri also. And I do wish that civilization beyond Earth was more similar to that. But in any case, so what it boils down to,
right.
what it boils down to is that there are both ethical concerns,
Right.
and concerns that are direct contradictions to the aim of lab-grown meat to cut out cows, and monetary concerns that matrigel and FBS are super, super expensive. If those can be alleviated, then lab-grown meat is probably something that could really compete in the marketplace.
Sure. Like if Russia and America didn't exist, maybe Germany could have won. World War II.
I'm going to say, let's take a break, and then we'll get back to it.
Hi guys, this is Donatello Iglesias. And if you're like me, you've been listening to our sister podcast, Petri Dish. And you want to know what's in your body. You want a fecal transplant. But the fecal transplant companies right now, they send you a vial, and sometimes the vial, it's too small for all the poop you have to give it. Or maybe it's just a little too big and, you just kind of feel small again that day. Well, now you can analyze your feces from the comfort of your own home. Sign up for Poops, and you'll get your own fecal analyzer sent to your home. Plug it into your phone, probably go into your bathroom and go nuts. Maybe you want to wipe off the rest of your phone, but in 30 to 40 minutes, you'll have your own free analysis of your entire gut microbiome. So don't wait, sign up. Figure out what's in your gut with Poops. That's P-U with an umlaut, P-S. Poops. Set your feces free. I guess as a child I watched a lot of Voyager, and I would watch Neelix in a tight apron walking around the kitchen making lab-grown foods and feeding all the beautiful people of Voyager. And so I always thought lab meat was like a brilliant idea. But I have an epiphany now that maybe lab meat doesn't matter that much.
God, I thought I was going to get through the entire rest of my life wuthout thinking about Neelix.
Neelix.
Oh, Jesus.
Always mixing up with Snarf.
Yeah, he's like Snarf
Yeah.
from the Thundercats.
But hey, don't distract me, Sean. but so what I'm getting to then is like why I have all this excitement, but to the average consumer, to the average person, like why would we ever even care about lab-grown meat then? Like it sounds like it's just super hard, has all these hurdles, just sounds like kind of a crock of bullshit.
That's a really fair question to ask. And basically, both this and to a certain extent, things like Impossible Foods and Beyond Meat were all kind of spurned by this truth that the worldwide demand for meat has been increasing, but at the same time, meat can be extremely, the production of meat through livestock can be very destructive to the environment. Cows can be very water intensive, they can be extremely land intensive, and they're also a pretty large producer of greenhouse gases out their butt.
Let's take a step back real quick. So cows, they make climate change by farting?
Yeah. So cow butts emit a lot of methane, and that basically results in a pretty considerable greenhouse gas emission.
So you're saying climate change is real?
God.
You saw it coming.
I don't.
You knew I was going to say it.
I'm going to be honest. I did not see it coming.
You didn't?
Oh my God.
Okay, we are. So let's just presume for this conversation that you liberal cucks are right and climate change is real.
Fuck. Eventually, someday, we will do a climate change episode. I'm just too tired. I can't do it right now. Things are too dismal. When I'm more hopeful.
Yeah, I do believe in climate change.
Oh my God.
Or do I? Listen in.
So, about 15%
Right.
of greenhouse gas emissions are from cow butts.
Is it all livestock or just cows?
So, most of the greenhouse gas emissions are from ruminants, which are grass-eating animals that usually have multiple stomachs to kind of process and build up more of this methane.
Because of their microbiome.
Because of their Last episode.
Oh.
Bow, 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 bow. So, compared to like goats or something like that,
Yeah.
one cow will produce more methane than several goats.
Wow.
But also, there's way more cows out there than goats because not as many people eat goats. So cows are probably the main contributor.
So cows are like a uniquely big blaster of greenhouse gases amongst livestock in general.
Yeah, my understanding is that when it comes to land usage or like maybe environmental ecological destruction, pigs can be comparable. But
There's just a lot of cows.
Yeah, there's a lot of cows, and pigs don't produce as much methane as cows.
Well, that gets me to the next thing, right? So there's just the fact that cows, we have a lot of them, they make a lot of greenhouse gases and thus contribute heavily to climate change. Also, land use. Cows are just inefficient vis-a-vis how much land they need, right?
Yeah, there's like a cool ivory tower economist efficiency point to it.
I don't like them.
But also, there's kind of the more liberally cuck argument of like cutting down the Amazon forest to make
Sure.
more land for cows.
Well,
Right.
and this is another one of those cases where economics and maybe morality actually collide, right?
Right.
Or not collide, but like come together because cows using land inefficiently is important when you could be growing soy
Right.
on that same amount of land or some lame crap like that. And you would yield so much more protein and there's so many Del Taco burritos compared to if you had cows there, right?
Right. And so when you look at the numbers, lab-grown meat is thought to be significantly more efficient in terms of water and land usage.
Right. Just to rehash what the number was that like one cow that you don't even kill gets you 80,000 quarter pounders.
Right.
Okay.
And that cow is fine. You know what I mean? You can
Right.
put them up at the Ritz-Carlton, have them hang out for a while, and then take another biopsy punch later. So we have this lab-grown meat, and in terms of land usage, water, it's better. In terms of energy, estimates are really all over the place.
Interesting.
So in some cases, it's considered maybe more energy efficient. And in other cases, it's considered to be more energy intensive than just like letting cows be out there. And
Right.
that's kind of taking into account, oh, the sun shining and getting converted into grass and cows eating and all this shit.
But when it comes to energy, the tricky thing there is it depends on what energy are we using in our laboratory to make this meat, or factory at that point.
Right.
If the energy is renewable, then it's a net boon. If the energy is still like just like shoveling Appalachian people into a coal furnace, then like it doesn't work. It's maybe it's a boon for the electoral college, but it's not a boon for, you know. I don't actually support that.
I can't believe you've done this to Appalachia.
I actually quite like Appalachia.
Where is Appalachia?
It's in the movie Logan Lucky, which was quite good. I wish more people saw it.
Is Kentucky Appalachian?
No,
it doesn't matter.
all I know is West Virginia.
It doesn't matter. This is plenty fucking
The movie
stupid already.
Deliverance is Appalachia. Squealing like a pig.
All right.
Okay,
So, in scheme of, like, should we do this because climate change and land usage and ecology, I think replacing having just a shitload of cows out there
right,
does seem like it'd be a good idea.
right.
Okay?
If we can figure out the fetal serum thing, because the fetal
Right.
serum would still imply killing a bunch of cows.
Right. Assuming that we get everything perfect with this.
Right.
Which, by the way, right now, because of things like the fetal bovine serum and the matrigel and all this stuff, we're talking about like $1,000 a burger patty. Okay?
Jesus.
So, cost
I've only
me
spent that much money on a burger once, and it was in France.
is 100% Cambodian.
Yeah. Cambodian what?
But we need to bring the prices down. Okay?
Right. It's thousands too much.
And, you know, in a marketplace where you have Impossible Foods and Beyond Meat, and they also, you know, hypothetically will eliminate having to have pastures of cows out there, can you really justify all the time it would take to make this thing work out? But I will say that there is one area where lab-grown meat may someday, and I'm talking about like decades from now,
Okay.
but may someday be the thing that would actually help us lower the amount of cows out in the pasture.
What's that?
And that's like steaks and stuff like that.
Okay.
Like, I think in all of this, people, it's really easy to kind of talk about like, oh, dude, like the Whopper, you know what I
Right,
mean?
but
Like
we're
the Impossible
actually
Whopper.
only talking about burgers and burritos right now.
Yeah, so, you know, like, it's really easy to take a bunch of plant protein and kind of shove it together into something. If, like, what does ground beef really look like anyway, right? Like, that's
Right.
all messed up. But when you have, like, a pristine ribeye steak or something,
Right.
it's really hard to take a bunch of plant protein and, like, extrude it out into some kind of shape that's going to look like a steak.
Or an authentic Szechuan monkey heart.
Right,
Right.
exactly.
Yeah.
You know what I mean? If you're sitting down at the table and you want a little bit of that primate heart inside of you.
You hear the screams in the back. Like, it's a whole experience is what I'm trying to say. It's an organic experience. It's hard to replicate through lab-grown meat.
Did you do the monkey screams for the intro?
No.
No? Because you could have nailed
I
it.
could have nailed it.
Yeah, don't let those monkeys come in and take your job. Uh-oh. All right, I'm sorry. Anyway, so with something like a steak, though, you have kind of a more complicated situation, okay? The same reasons why you can't just go to Impossible Foods and be like, hey, make me a steak out of your soy protein.
Right.
The way that we're making meat in the lab-grown meat side is also not sufficient.
Well, what's the difference with the steak?
Steak, kind of like a full organ, like a heart
Right.
or a kidney. It's got all these different tissues mixed together in really, really clear and important ways.
That's like the marbling. When you
Right.
get a really good steak, it's marbled, and it's hard to replicate that in a lab.
Right, especially if we're growing the fat and the muscles in different
Separately,
dishes.
right.
So you need to be growing them together, and you need to be growing them 3D. Right? So you need to be able to have this whole scaffold where you have cells in different spots and they're growing together. And all of this is to say that this is a technology that is being worked on. Okay, so this is out there. It's called 3D printed organs. It's mostly being used for legitimate purposes, like printing hearts and kidneys for transplants. Right. So this is that's one of the main goals of the technology. But hypothetically, that same technology could be used to 3D print a steak. And when you do that, you're not going to be doing it the Impossible Foods style. You're going to be doing it lab-grown meat style with actual meat cells and actual fat cells.
It's kind of like how the moon landing, which did happen. The moon landing, right, had all sorts of technologies it needed to accomplish the moon landing that were clearly more important. But just like one of the side technologies they needed was just a new lubricant for inside the astronaut suits, which turned into Jerry Curl. God damn. And it's like that. We're trying to make hearts and livers, but we can apply the same technology for things that are honestly more fun and delicious, like making steak.
So I know that at some point you decided Jerry Curl was going to be the through line for this episode.
It's not. It's just in there.
I don't know why you did it. All right. To kind of recap, I think that realistically, the main justification for any of these meat replacement technologies is that the livestock industry, and realistically, mostly cow side of it,
right,
is potentially destructive in a lot of ways. And we want to, at the very least, be able to take a dent out of it.
Right.
When it comes to that, all other things being equal, probably the plant-based options are faring a little better right now. But
it kind of sucks to eat plant-based options.
And realistically, are people going to stop eating cows if you only give them burgers?
Right.
They want the other stuff. You know what I mean? People, yeah.
Cabeza.
Sure. Heads, yeah, sure.
Culo.
Uh-oh. But when it comes to steaks, maybe the meat-based, lab-grown option will eventually give us that technology.
Yeah.
You know, I do want to say, as kind of like a closing note on this idea, all of this stuff is about replacing what already exists. But if we have this technology up and running, we can go a step further. We can make better meat. You know what I mean? Like we can include more nutrients in the meat. We can have more vitamins involved. We can include a higher level of protein, or we can use different fats, tailored fats that are less unhealthy for you. So it'll still taste really good, but it won't have all of the negative cardiovascular effects that some of the animal fats can have.
That's interesting.
And so I think that is an option that, you know, it's still out there because, hey, if we're talking about $1,000 a patty, technology's not there yet, right?
Right.
But if we get there eventually, maybe we can start to think about how can we take this and move it to the next level so we truly have some of that future meat from the Jetsons you were talking about.
The Jetsons. What's interesting to me about the whole conversation that I think we haven't even talked about yet is how it exists within... Like, there's an environmentalist and an ethical reason, and hopefully someday an economic reason, to pursue all these options. And it sidesteps entirely all the hippies in Marin County that would never even eat it anyway. Even though they want to, like, quote-unquote, save the planet, they wouldn't eat it anyway because it's all processed. Right? Like, that's what's funny is you're talking about how you can supplement meats, and it reminds me of the more nuanced conversation around different ways to genetically modify vegetables that are very rational and that are very interesting conversations. And then you walk out the door and then there's a protester who's like, don't fuck with my vegetables in any capacity, whatever it does, no matter who it saves, because like maybe Gattaca, right?
Yeah, someday we can talk about this, but it's fascinating how many different and somewhat overlapping identities and groups there are. Impossible Foods worked very hard to make their burger gluten-free, but in the process switched to soy and then had to, first of all, include soy, which some people don't like, and second of all, because of volume, have to use GMO soy. And so there's a lot of people who don't like it now because it's genetically modified.
This is why
we can't have nice things. You know what I mean? But in any case, I think that's all part of kind of a bigger story.
Right. Something for Donatella Iglesias, probably. Our sister podcast, not brother. Sister podcast. Yeah. Okay, guys. Well, thank you so much for joining in. That's our conversation about lab-grown meat. I was someone who I think came into the subject with a weird mixture of knowledge and entire misinformation, mostly because of the ads on the side of the Del Taco around the corner of my house. And so this has been really good for me, and I really appreciate you sorting out all this crazy crap for me, and thus proving to me how there really is no ethical way out of this bind. I really should just keep eating meat.
Yeah. God, there's gonna be so many angry vegans. Oh, how terrible. Yeah, so thank you everyone for listening. And, you know, we got a bunch of stuff now. We got a Patreon page, patreon.com/Petri Dish. This podcast is now available on all kinds of stuff. So I don't know if you first picked it up on Podbean, but now it's on everything besides iTunes, and probably iTunes soon. So it's on Google Play, it's on Stitcher, it's on Spotify. Yeah. We nominally have a Facebook page and Twitter, and so all of these things are possible. And these are kind of early days, but I think eventually, once we have kind of a listener base and everything, we do want to hear from you guys about, hey, topics you want to know about, or if you thought the episode was interesting, or if we missed something or something like that. And so our email address is petridishpod@gmail.com.
Guys, email us, sign up for our Patreon. If you sign up for Patreon at any level, you'll just get like increasingly large volumes of bovine fetal serum.
We can't afford that. That is actually very expensive. I can't do that.
We would
I
lose so
cannot
much
sign
money.
off on that, guys. That may be not doable.
We'll just send you a cow fetus then.
All right,
and you can get the serum out of it.
We need to thank our producer and sound engineer and sound lord Stacy Song, and then for all of the graphical assistance with all of our artwork that you're going to be seeing on the Patreon and everything like that, we need to thank Brian Allen. And then we need to thank you guys for listening in.